Thank you for joining us today as we continue our study series. This series today is on science and origins, creation or evolution. Other studies we do are on the two creation accounts in Genesis and Revelation and end times. You can reach us anytime at our web, berniefam.com, and hopefully soon at our new site, which is targettruthministries.com. Our ministry delivers God's truth to jail and prison inmates. If you would like us to mail weekly studies to someone in jail or prison, please email us with their name, their ID number, and their address. Now today, we're going to resume our discussion of the Big Bang. And this is kind of where we left off last time. We'll review just a little bit. In 2008, the Hubble Space Telescope team announced that they had a new record for the oldest galaxy. This galaxy is nearly as old as the Big Bang itself, and yet it appears to have formed quickly. Science Daily reported that a team member said, "We certainly were surprised to find such a big young galaxy 13 billion years in the past." The current theory for a time frame for the beginning of the universe is 13.5 billion years. According to conventional science, however, discoveries like these challenge the conventional understanding. Science Illustrated from August 2008 discussed the latest problem for the Big Bang theory. Both the WMAP satellite, and that stands for Wilkinson Microwave Anisotropy Probe, and the radio telescope at the Very Large Array in New Mexico, they have confirmed that the very large cold spot or void has been discovered in the universe, which does not match up with current theories of how the Big Bang created the universe. Astronomer Lawrence Rudnick and a team of astronomers at the University of Minnesota are examining the data. Current theory is that the initial expansion of the universe immediately after the Big Bang would have evenly distributed matter throughout the cosmos. This is a fundamental principle of the Big Bang, and it's called the Cosmological Principle. Rudnick said that scientists will need to reevaluate what processes led to the development of structure in the universe. The void makes it necessary to explore new theories about the way the universe formed. So science is experiencing a lot of problems in understanding the Big Bang and redefining, as new information comes along, redefining how this event took place and how our universe formed. The current Big Bang theory also has other problems. These concern the cosmic evolution process, which is the evolving of time, space, and matter. If the universe expansion is too smooth, then the matter never clumps, and clumping is needed to form galaxies. And if the universe expansion is too rippled, then the matter would be pulled back into massive black holes, and again, galaxies could not form. No theory has yet been accepted to satisfy the existing evidence. So you see what the problem is the universe in this Big Bang supposedly started expanding. And of course inflation took place at the beginning, but the expansion, they say, had to be smooth. It had to have just enough ripple in it so that clumping, condensing of matter, could start to take place. If it expanded with ripples, then these huge black holes would form and they'd suck all the matter into black holes. You wouldn't have galaxies. And yet if it's too smooth, then matter never condenses. It never forms into galaxies. So it had to be just right, kind of a Goldilocks situation. So whatever happened before the Big Bang? I mean, we can talk about the Big Bang, but was there something before the Big Bang? And this is always a big question, too, between scientists and theologians. Well, from science, the latest conventional scientific explanation to answer the age-old question of what happened before the Big Bang is that this was addressed in Astronomy magazine. Quotes an article and this article in Astronomy magazine quotes an article in Scientific American by Andre Lind of Stanford University and Nobel laureate Steen Weinberg. And here's their quote: "There wasn't a beginning. There is a constant genesis or boiling of universes in an ocean of cosmic nothing or nirvana. Now, this newest scientific theory seems to require a lot of faith, something like the Bible. So again, the Bible and science aren't too far apart from each other. Moving on, we're going to discuss inflation and expansion. Inflation and expansion. You'll recall that we read there in Isaiah 40:22 that, and we also read in Jeremiah, and there's lots of other places where it talks about how the universe in the very beginning expanded greatly. Evidence gathered by the COBE satellite, and COBE stands, C-O-B-E stands for CO for cosmic, the B for background, and the E for explorer, Cosmic Background Explorer satellite, was analyzed by Edward Wright of UCLA, Charles Bennett of the Goddard Space Flight and Center, astrophysicist Joel Pimrek of UC Santa Cruz, and George Smoot, astrophysicist with the California Lawrence Berkeley Lab. And this supported the theory that the universe came into being and did the bulk of its expansion as we know it today in 1/1000th of 1 second. Now, COBE satellite, it collects microwaves, which is theorized were formed from light waves that were stretched when the universe was formed in that first fraction of 1 second. Now, Gerald Schroeder, who's a nuclear physicist, Dr. Gerald Schroeder has established that the exponential factor, expansion factor, in other words, how fast it expanded, that this expansion factor of the universe would be at 10 to the 12th. And this means the universe was established in a matter of days. Alan Guth, in the Inflationary Universe, when he wrote about that, he gives the figure of 10 to the 20th, which is even faster. Astronomer Joseph Silk in the Big Bang agrees with Schroeder that 10 to the 12th is a factor. 10 to the 12th would equal 6 days of time as measured by Earth's gravity when compared to gravity in space during the Big Bang. We should note that the term stretching of the heavens appears 17 times in the Bible. Now, I'm going to show you a little math here in just a couple of minutes about how this works out into be 6 days. Dr. Humphreys, in the book Starlight and Time, he wrote that the outer masses would inflate in distance exponentially up to 10 to the 20th times the speed of light. This would account for the billions of years of distance being accomplished in only a matter of hours. Alexander Villekin, a physicist at Tufts University in Medford, Massachusetts, he provided science with the latest scenario for how the huge universe did the bulk of its expansion or inflation as we observe it today, in only a fraction of the very first second of the Big Bang. Science has little argument over the universe expanding. The argument is whether the fraction of a second in that first instance of expansion was a trillionth, a billionth, or a thousandth of a second. Now, here's what was happening. The Big Bang takes place, and immediately there's a huge stretching, instantaneously, within that first second. The argument's over how fast it occurred in that first second. But the bulk of the universe did its expansion in that first second. It's kind of like this slinky here that I've got. This slinky accounts, we can say that this 2 inches worth of a slinky is the distance light would travel in, say, 10,000 years. So if we were in a telescope here on Earth and we were looking back into the light traveling back into distant time, we would see 10,000 years worth of light travel during this time. But in that first instance of the Big Bang, what happened was, just like this slinky can stretch out, it's still the same slinky, still the same light wave, but it's stretched out over a massive amount of time, and that 10,000 years can now appear to be billions of years. And that's what science is talking about in that stretching factor. When we get to the speed of light and age, our universe today originated out of nothing. Nothing tangible. Matter existed in the form of energy. Albert Einstein theorized, and science has since shown, that energy can become matter as energy consolidates. It reaches a critical mass. The forces are pulling so strong that it's like a black hole where even light energy cannot escape. When critical mass occurs, then energy explodes and a hyperinflation or stretching takes place. Energy blows right through what they call an event horizon and in effect becomes a white hole where light escapes from. In other words, in this Big Bang event, light would expand so fast that gravity could not pull it back in. When the black hole occurs, gravity is pulling everything back into the black hole and you can't see the light because it's going back in. But in the Big Bang, it expanded so fast that the light escaped in all directions, and you could see the light going past the event horizon of the black hole where all that massive energy is. You could see the light escaping, and it becomes like a white hole where the event horizon where the light is escaping from. Energy blows right through the event horizon and in effect becomes a white hole from where light escapes. The event horizon is that point where the pull of gravity is not so strong as to pull the light back. Light can escape past the point of the horizon and in effect produces a white hole. As matter escapes, the event horizon shrinks inward. So as more and more matter escapes, this event horizon shrinks back. The black hole gets smaller, in other words. The energy from this event includes extremely high frequency energy, much higher than the frequency spectrum of light, the microwaves. The universe does the bulk of its expansion in this very first second of this expansion or stretching event. And God's word, as we said before, describes that 17 times in Scripture. As this hyper-frequency energy is stretched and slows, it stabilizes within the frequency spectrum of visible light. And that creates a path of light from all points of the newly forming matter, thus giving the appearance of light billions of years old. So in other words, as this light, as the microwave's energy expands outward, it stretches outward, it slows down, and eventually light is the spectrum of energy that we're seeing. And it looks all the way back to the point of the beginning. And that's what we look at when we look through a telescope. We look at light patterns going all the way back to the very beginning of time. Evidence compiled over the last couple of decades and presented to the physics conference at Warwick University in 2005 shows how the speed of light has been slowing down from the creation event, the Big Bang, as they described it, even though science has always assumed that the speed of light is constant. So in other words, there's evidence being presented today that the speed of light is not constant. It can speed up, it can slow down. They had hyperinflation, and we can also see that light can slow down. As this energy slows and cools, it becomes matter, just as Einstein theorized, where matter and energy are interchangeable. Matter is then consolidated by electromagnetic forces, and these forces are measured by science as 10 to the power of 40 times more powerful than gravity. We'll come to that in a while too, about what is causing our universe to form. Is it gravity forces or is it electromagnetic forces? Anyway, electromagnetic forces are 10 to the 40 times more powerful than gravity in space. And with forces this great, the mathematical calculations show the universe we see today could have originated in a matter of hours, not even requiring a whole day. That's pretty amazing. Now there's another way of looking at this too. Light could have also been made at the same time God created the universe, thus giving the appearance of light billions of years old. That's a very simple way of looking at it. God knows we're simple people. Maybe that's the way he did it. And there's another way of looking at it. Light in deep space travels faster than light close to Earth when measured with the time reference of the gravity of Earth. This effect is called gravitational time dilation. And this time dilation gives the appearance of light billions of years old, but indicates the universe is actually very young. This effect of time dilation has been tested by scientific experiments conducted by J.C. Haffele and Richard Keating using cesium clocks, which proved Einstein's theory. Both Dr. Gerald Schroeder and Dr. Russell Humphreys have shown that 6 days of time on Earth, which is gravity, are equal to billions of years in space, which has almost no gravity. Thus, time and age are relative to the point in space from which they are measured. I'll go here to take a look at another section here. Yeah, it says, as early as the 1800s, and this is about the speed of light, as early as the 1800s it was verified by science that the speed of light is not a constant. It does slow down when it passes through water, meaning that when it passes through anything, it slows down at different rates. Actual observations by Russian astrophysicists V.S. Trotsky and Barry Sutterfield and Norman Trevor of the mathematics department of Flinders University in Australia indicate the speed of light has been slowing down at an exponential rate ever since the first second of the entire universe coming into being. This would additionally change decay rates of radioisotopes and further verify a young Earth age. In other words, if the speed of light is slowing down, everything we measure in regards to age could also be changed into lower numbers. This is additionally supported by scientist T.C. Van Flanderen, who reported that 26 years of actual observations suggested that atomic clocks are also slowing down. It's funny today, we use the atomic clock to test our time, but atomic clocks are slowing down too. They're based on the speed of light. The principle of the speed of light always being constant is under further attack from physicists including Dr. Linjun Wang of the NEC Institute at Princeton, who has indicated that light pulses can accelerate up to 300 times faster than the normal velocity of light. And also physicists at the Italian National Research Council they've transmitted microwaves 25% faster than light. In April 2005 at Warwick University, a physics conference, several scientists reported the speed of light may be slowing down. So this has become part of our science lexicon today. People realize that the speed of light is slowing down. Well, now, we're going to take a look at some math here and try to make sense of how the speed of light could translate into days instead of years. And this all has to do with age. The big problem for science, agreeing with the Bible, is always age. Like I said before, the science and Bible agree on many things. It's the issue of age that seems to complicate things. Now, to understand math, you'll notice the first number on top, 10 to the 1, equals 10, and I've underlined the little o. The 1, the exponential factor of 1 after the 10 means 1, 0. So 10 to the 1 equals 10. 10 to the 2 equals 2 zeros, or 100. 10 to the 12, which is the exponential factor that the scientists say the universe expanded at, would be 1 with 12 zeros after it. And that's what we see there. Now, if the age, using current observation, the speed of light equals 14 billion years. Remember they said the age of the universe is 13.5 billion years. So, looking at that number there, let's just assume, let's round it off to 14 billion years. That's what conventional science says. So if we assume that the age using current observations, in other words, current observations is the speed of light today, that we would see that there's 14 billion years of time looking back into distance. We'll accept that. Now let's figure out how many days that is. And we'll give the scientists all the room they need. Instead of 365 days, we'll multiply it by 400. We'll just round these numbers up to give them as much time as they need for age. 400 days per year. If you multiply 400 days times the number of years they say the universe is old, that comes out to 5 and then 6000000 total days. Okay? Now, if the inflation rate was 10 to the 12th per science, who say that in the beginning the inflation of the universe was 10 to the 12th, it expanded so fast, then the actual time of the origin of creation is 5.6 days. You take away those zeros one at a time, 12 of them, and you end up with 5.6 days. There were all those trillions of days, but now there's 5.6 days if you bring in effect, if you calculate into the effect the inflation factor at 10 to the 12th. So that's how we arrive at the 5.6 days. In other words, God didn't really need 6 days. And if the inflation factor was even faster, as some scientists say, that it was 10 to the 20th, then that means that it didn't even take 4 or 5 days. It might have only taken 1 or 2 days. In other words, God can do whatever he wants to do. And like we said before, he may have just formed the universe in a matter of just by creating it in a single day and making the light stretch out that way to begin to look like it was old. We're going to look now at dark matter and dark energy. This is an issue which has plagued science for a long time. And read this here. It says, current Big Bang models. Now we're going back to the Big Bang again. Current Big Bang models attempt to use dark matter and dark energy to explain what we see happening in the universe. First, science measured the density of all matter in the universe, and then they realized that there was not enough known matter to hold the universe together. The gravitational influence is measurable, and it cannot be accounted for by the visible matter that we have. In other words, the universe should be flying apart, but something is holding it together. There's not enough matter, gravitational forces, to hold things together. Things should be flying apart. The atom itself should be flying apart. The galaxies should be flying apart. The whole universe should be flying apart. But they're not. Something's holding things together. About 95% of matter is unaccounted for, according to the scientific measurements. In other words, what we see out in the universe, all the stars, all the planets, the whole universe, everything we can measure only accounts for 5% of what's needed to hold things together. 95% of matter is unaccounted for. So science is calling the unaccounted for matter, the missing matter, what's needed to hold the universe together, they started calling it dark matter. Then, in the late 1990s, science discovered that there is an expansion of the universe going on today. In other words, the universe is actually speeding up. For a long time, people thought that the universe had expanded and this is as big as it's going to get. There's something stabilizing in here. And they thought, well, maybe there's enough gravity holding it together from this dark matter. Remember, 95% of the universe we can't see. We don't know what's holding it together. Something out there holding it together. So they thought that, well, maybe there's this dark matter holding things together and we're stable. But then in the 1990s, they began measuring the universe even more tightly, and they realized that the universe is actually expanding faster and faster. And so, because of that expansion, that it's not stabilized and it's not slowing down, they had to be something that was offsetting the dark matter. And the dark matter was supposed to pull things together, but now they see it's still moving away, so the science began calling that force dark energy. And today the theory is that dark matter is visible matter, everything we can see accounts for 5% of the universe. That hasn't changed. And they say that dark matter accounts for 25% and dark energy for 70%, supposedly. Of course, we know from Colossians 1 that we read earlier that there is something holding everything together, the atom, the universe, and everything else, and that is God. Now, as reported in Science News, and also in the Astrophysical Journal, dark matter, the matter of science, the matter that science thinks makes up over 80% of the universe, it cannot be found within our solar system. There is a force, a very large force, that science cannot identify. The long-awaited results of the dark matter experiments have come back, and the invisible matter is still invisible. They did some studies, and they did tests over a 15-year period trying to identify what this dark matter was, and the tests came back, and they cannot identify anything. Now, the reports go on to say that they believe that this doesn't mean that the dark matter doesn't exist, but that science will need to reconsider what shape the dark matter takes place in. According to their own quote in the Astrophysical Journal, this is a major setback in our understanding of the age and formation of the universe. According to the reports, that dark matter cannot be identified and measured. Of course, science classes in high schools and colleges will not consider this setback when they continue to proclaim, as you read in the science books, that the evidence that the universe is billions of years old and that there's dark matter and dark energy in existence. That's what you'll find in the textbooks. Let's see, 25. Current Big Bang models must assume large amounts of what's called dark matter and dark energy. matter and energy which cannot be identified yet, but is assumed to be there. Up to 95% of the universe is supposedly dark, according to current Big Bang theory. Therefore, science bases its theories, now this is important, science is basing all its theories on 5% of the available evidence we can identify. Now that may be a good theory, but it's very poor science to base everything you understand on only 5% of the information. We're going to move to an area now called clumping and gravity and electromagnetic forces. In other words, if the dark matter and dark energy are there or aren't there, if gravity is the big force, what's holding things together? What causes things to clump together? What formed the galaxies? What formed stars? This is important in everything in cosmic evolution. Conventional science theorized that it would take 15 billion to 200 billion years to form our solar system through a process called clumping, where matter condenses into stars. Now, considering the theory that over long periods of time, star clumping clouds of matter have condensed, giving us galaxies, stars, and even planets, a report has been issued by NASA's Ames Research Center. Scientists Louis Amendola, Scott Sanford, and Dutch scientist Xander Tillens, and German astronomer Tom Herbst in the Astrophysical Journal. And the report says that revisions will be needed to current theories that hold that over long stretches of time the star-forming clouds condense to give birth to other stars. Scientist Stanford is quoted as saying it means that all of our models of galaxy evolution are flawed. The Hubble Space Telescope proved that the star nurseries pictured in school textbooks cannot be proven as sources for newly forming stars. Stars cannot form from the condensing gases because scientists tell us that heat forms from any condensing action and actually causes the gas to expand. Evidence of measuring gas clouds in space shows expansion of the clouds in all cases, not contraction. In other words, the clouds are all expanding. Those pictures you see in the textbooks of the star nurseries and a gas cloud, science has proven that those clouds are expanding. They're not condensing into stars or galaxies. I want to thank you. We'll resume this on clumping gravity next time. I want to thank you for joining us today in this series of seminars. May God bless you each and every day. And until next time, please pray for our jail and prison ministry, BernieFam.com.